make maps. Actually, that's my shtick. So here's a funny story. So I have cartographer in my title, but I don't make maps. All right. I'm going to let you mull that one for a moment. And here's why. So when I was a graduate student, undergraduate student back in the dark ages, many, many years ago in the 80s, I was a computer science student. I thought, yeah, this is what I want to do the rest of my career. Well, I had to take an introduction to mapping class as part of just one of my university requirements. I thought, well, this is cool. So I went to the professor and said, is there something that combines, the maps, the computers, and light bulb over his head went off. Like, oh, I hooked another one. Awesome. So I work in the field of geospatial information science, GIS, mapping, however you want to call it. So I'm a mapper. That's kind of the way I describe it to most folks. I used to try to describe what I do to people in very scientific terms, and eyes would glaze over and it's like, okay, yeah, I just make maps. Well, really, I don't actually make maps, to tell the truth. But my world is very data intensive. So that is how my background applies. You might think, oh, how's this guy going to be, making maps from high throughput computing? Well, guess what? I'm not. Well, not exactly. But we are doing a lot of work in terms of processing data. I used to think until about an hour ago when the University of Hawaii is producing 10 terabytes of data a day, I thought 100 terabytes of the data that we deal with is a lot. Well, not anymore. That's like 2 weeks in Hawaii. But that's you astronomers, you just like lots of data. We like data too, but it's map data, digital map data. So I just want to provide a little bit of background. So that's why, yes, I've got the title cartographer, but I don't actually make maps. So that's my shtick for the day. So the little unit that I work for in the Department of Geography, we are actually mostly public facing. We work with lots of folks on campus here at UW-Madison, but most of what we do is working with people from the general public, mapping professionals, helping them with technical questions. We get all sorts of questions. We get hundreds of questions every year from the general public. Could be as mundane as where do I find a photo of my farm, to very complicated land ownership questions, which we do our best to answer, or at least point them in the right direction, especially when it starts to get into legal matters. So we do a little bit of everything as it pertains to maps and mapping, primarily in that education, outreach, public service kind of role. So am I a researcher? Kind of, sort of, but more of a public facing public, scholarly service is what I like to call it. So that's just a little bit of background about who's standing here this morning. So I do want to talk about the data problem that we have. In the context, I almost feel a little apologetic because our use case, frankly, is quite simple. But I think a message I want to send you all, those of you developing the tools, that there's probably lots of people out there like me that have very simple use cases that can take advantage of the tools that many of you are developing. No, we're not processing petabytes of astronomical data, which is awesome and exciting and really interesting to learn about that. But there's probably lots of people, even on this campus, just like me, that can take advantage of these things. And the work that I've been doing has been directly facilitated by these high throughput computing resources that, frankly, I could do, but it would take me a lot longer to do some of this stuff than it has been with these resources, to make a long story short. So this has been really important. So here's our problem, essentially. So we've got in our current project, about 15 terabytes of data we need to process. Not a lot from what I've heard this morning. In all, we're managing about 100 terabytes of geospatial or map data, if you want to look at it that way. And for our current batch of data that I need to process, it would take about a month and a half just firing up a PC, letting it do its thing. That's kind of the way we've always done things in my world. But I knew we could do better. I've been aware of the Center for High Throughput Computing here on campus, and aware of some of the great work that they've been doing for quite a number of years, actually. Back about 10 years ago, we had a project to map the land cover of Wisconsin. What I mean by land cover is what types of trees are where, what types of wetlands are where, those sorts of things on a statewide basis. So it's taking many, many terabytes of satellite data, processing that, actually using a machine learning algorithm approach. And we, at that time, chose not to use CHTC. And I'm going to talk a little bit later about why, because I think that's relevant and important. So I've known about this, and finally, I think I reached out maybe first to Christina, and we talked a little bit about what we were doing, and she's like, oh, here, let's try this. And that was great. So that's gonna be kind of one of the recurring themes, is that people connection, which I think is really critical. So I want to provide a little bit of context here, and that is, what do I mean by historic aerial photography? So one of my colleagues, her name is Jamie. Jamie maintains an archive of about 260,000 individual frames or individual photographs in a library right here on campus. 260,000. Many of those photos are, well, some of those photos, I should say, are approaching 100 years old now. Guess what? They're eventually going to just rot away and disappear. They're in generally good shape, but working together, we really feel a need to digitally preserve and archive this information, which is leading to the things I'm talking about today. It's really important information that folks use for things like environmental impact statements to look at. This is the Madison campus if you're not from town here, from 1937. Lawyers use this kind of stuff all the time for looking at, land disputes, and the list goes on and on and on why people are using this kind of information. Here's another view from 1962. Yeah, 1962. If you zoom in a little bit, for those not from town, this is Camp Randall, the stadium. You can actually zoom in to a point where each pixel in this image represents, I believe it's about 8 inches on the ground, which is very high resolution. So we've got lots of data like this. This original image off the top of my head is around 400 megabytes in size, but there's like 30,000 of those. So it's, for us, at least, it's a fair amount of data. So something else that's changing in recent years. So this is actually a picture from the what's called the Aros Data Center in Sioux Falls, South Dakota, as a U.S. geological facility. And it's kind of my Raiders of the Lost Ark picture a little bit, but these are individual canisters of film. You think about the old school 35 millimeter canisters of film. Well, these are about like so, and they contain the original right off the aircraft photography, and they have millions and millions of frames of photography. Well, they too know that they need to get this stuff digitally preserved. And so they're going through and starting to scan all this stuff. So we have a problem where we're getting lots of imagery, both internally and from federal partners that we need to do something with. Okay, so I have to digress just a little bit. So yet another Nebraska connection. It feels like there's lots of Nebraska connections today for whatever reason. So I used to work for the University of Nebraska for 7 years in the early 90s. And while I was there, we purchased a 1 terabyte. This is like, now I'm the old guy in the room. 1 terabyte network attached storage device cost $100,000. Now you can go on Amazon and buy something the size of your thumb for $100, and that's a name brand, SD card. You can buy a cheap one for probably $40. That just blows my mind. But this is really important and relevant to our work because we are talking about archiving and storing basically forever information that's now in file cabinets. So for us, the availability of storage, the constantly falling prices of storage is really important. So I want to mention that because it's relevant, not just because of Nebraska, because of the storage. So, in the traditional way, there's really no rocket science here, quite frankly. I could fire up my PC, run a batch script, and convert thousands and thousands of images in serial mode. My world is serial, large and large, by and large, right? So, but that might take a week. And in the past, it's like, okay, I guess I'm going to wait a week. Hope there's no network glitches. Hope that things don't die. Hope I didn't screw up. And it will. And I'll go back and do it again. All right. So that's something that I've always done. So fast forward. So I, again, have known about CHTC here on campus and want to give this a go. So how can I do this differently? All right. You all know the technology. I'm not going to show code because you know the code better than I do. But here's one use case, 88 input files, about 40 gigabytes or so. All I'm doing, frankly, is converting some formats, applying some georeferencing, as it's called, to basically bring it into a map space and a couple other fairly minor things. Each one might take a minute, maybe, if something like that. And if I do that on my local PC, for one county, we're in Dane County right now. If you're not from around from Madison, an hour and a half. Yeah, that's not bad. If I only had to do one county, 1,200 square miles, while Wisconsin's what, 66,000 square miles. So I'm going to be waiting a while if I do it the traditional way, right? So if I were to scale that up, about 80 hours of processing if I did it on my local PC. Well, you see where this is going, I think, by this time. I can't speak highly enough for the folks at CHTC, the facilitators, other folks on campus. It's been a really great experience working with those folks. things like Open Science Grid, OS, what was it, OS Pool. I had no idea what you guys are talking about. I'm thinking here on campus, so I'm learning a lot today. But my work has been really isolated here on campus. So yeah, you know the story. Do this in parallel. Well, instead of one file at a time, 500 files at a time, 1,000 files at a time. Yeah, guess what? 5 minutes. Okay, well, this is a win, mostly, because it wasn't perfect. We'll say it that way. But first I saw that and thought, okay, that's awesome. Well, what if we scale this up? Again, I'm just going to cut to the chase. Well, the real limitation, and I'm going to talk a bit about this, has been transfer time, data transfer to get the stuff there to the thing, get the data transferred back to where I need it. That is the vast majority of the work involved. And this is only maybe, what was this? I don't think I have on here, a couple terabytes of data. So that was a major problem. Before I discovered Globus, which most of you probably know all sorts of things about, Globus is magic. I don't know how it works, but it works, and it works amazing, at least most of the time for me. So that dramatically changes the equation. But when I was first doing this, I ran into some problems, which I'm going to talk about in just a few minutes. But right away, the equation it's tilting in the right way, all right? I can save myself a ton of time doing something relatively simple, using this resource that's available to folks like me on this campus. So I want to spend the remainder of my time just talking about what are the challenges that I ran into? Because I'm just your average person trying to use these resources that you all are working to create. And what are some things that, maybe could have gone differently, maybe could be better? Call it feedback, not a complaint, you decide. But these are some observations that I guess I had. So that data transfers, I already talked about it. So if it was going to take a week to do the data transfers, it doesn't really matter how fast the computing happened, right? Well, I was doing some things that were probably pretty dumb, and I learned a better way of doing it. Then I discovered Globus. So we basically eliminated that, or I would say reduced that as a problem in the equation. But it's still pushing around a lot of data. For me, compute is not a barrier. It's the data transfer, the data manipulations, I should say, again, the data transfer is really where the barriers are. But they're surmountable, and they're going to get better as network speeds increase and all the rest, right? Globus, yeah, I already mentioned it. I don't know how this happens. 500 megabytes a second. I don't care. I just know it works. And it works really well, but that's really made my life a lot easier. So I really appreciate that also is a thing. So for a lot of my colleagues, like the slide says, command line can be scary. I grew up, went to college in the 80s, so I spent my time in front of a green screen on a VAX. So someone please tell me you know what a VAX is. Otherwise, thank goodness. I don't feel completely old now. So, I mean, to me, the green screen's oddly kind of comforting, so I'm totally fine. A lot of my colleagues in my field, they're used to GUI interfaces, yeah, maybe a little Jupyter notebooks now and then, but this is just the way these resources that you all are working on work. And we just have to be at peace with that, I think. But it's a barrier. And I'm going to talk in just a moment here about, well, how might we mitigate some of those things? But for me, no big deal. I'm totally comfortable with this, but not everyone is, frankly. This is the big one, okay? So I talked about this statewide land cover project a few minutes ago. So really the main barrier was like, that sounds complicated. We're not really sure how we're going to get all the data there. We're not really sure we're going to get all the data back. And this was 10 years ago, keep in mind. So there were some more challenges back then, but it was also just like, well, we know how to do this on a PC, and yeah, it's going to run for a week, but yeah, that's okay. It's not that big a deal because we'll get like 5 or 6 PCs. Sound familiar? And we'll let it go. And of course, you end up having to run that, dozens of times. But it was just trying to overcome that inertia of it's always been done this way. I don't claim to understand the psychology of how to overcome this sort of a situation by any means, but I think it's a real barrier to helping people understand, like, there's a lot of email between me and the facilitation team, trying to understand, how some of these things work. And they were very patient with me, thankfully. We got through it. I had to invest the time though. And I think part of the barriers are getting people to invest that time to benefit themselves, because guess what? Although in theory, a lot of stuff that I'm working on, you run it once and you're done. I've run these things probably 5 or 6 times by now because I realized, oops, should have changed that parameter. Oops, Didn't mean to do that. And here we are 5 or 6 times later, times if I were doing it the old fashioned way, guess what? Now I'm talking 5 or 6 months of data processing. That's not going to work. I'd have to live with things versus, statewide 90 minutes. That's pretty good as far as I'm concerned. So these are just some little tips and tricks that I have picked up. Start small, build from there. You all know this. I can't speak highly enough of the facilitation team here on this campus, and I'm learning you guys serve beyond this campus as well. I didn't know that, so that's amazing. I swear I'm not in cahoots with the facilitation team. I said this to Christina, but I mean, seriously, there needs to be like 3 times as many facilitators to help people like me effectively use these tools. I'm joking, but I'm not, because that human connection is really important. I would not have been able to do this without their very patient assistance moving this forward. I'm a reasonably well-informed, tech-savvy person, but I still had some struggles. The command line thing, that's a challenge, that's a barrier, I suppose, for a lot of folks. It's trying to help them get comfortable with things like that. I don't have any magic bullets for the psychology behind that, but I think there's ways to, as one of my colleagues puts it, what do I type again in the black screen? It's like, it's okay. And that's fine, because that's just not her strength. She's not used to that. She's used to a GUI and operating that way. So I think the training and the patience, everything else that can be done, I'm not in any way suggesting like, just get rid of all this command line stuff and start making a GUI for it. No, that's not real. But helping folks, be effective.
A quick question here.
Yeah.
Do you have any experience with notebooks rather than command line?
Like Jupyter notebooks? You mean?
Yeah.
I personally know, but I'm understanding that's a thing.
So maybe we'll use you and see whether you find it more gentle than command line based on your background. Would that be a step forward?
I think you just volunteered Christina and her colleagues for something.
Oh, yeah.
Yeah. And is Justin here? Justin H. There you are. Hey, nice to meet you in person for a change. He's been doing some work to try to ease the burden, and we've had, I think, good results, mixed results, though. We ran into some unexpected challenges trying to make things simpler, if you will, as far as dumping data into bucket and just magically processes.
But in terms of how it's being presented, because getting into GUIs and you saw that's a significant investment. But if we can, and that is also good as a cookbook, because it captures the process. So it may be an interesting exercise.
Yeah, it would be. I think that'd be great. And you mentioned it yourself, and the idea of a cookbook. I don't know what else to call it, but just examples. Maybe I was unaware of where to find such examples, but this is the challenge for, especially folks in facilitator roles, like trying to understand all the science, all the stuff even we heard today, to be able to help a person, right? Has to be a huge challenge for you guys. Andrew's up here someplace as well. There you are. That's got to be a huge challenge. Try to understand all that and say, well, okay, I think I understand what you're doing. I don't really understand your field, but let's try this. So the more that can be done to provide examples and like, well, maybe this applies, maybe it doesn't, I think is amazing. Maybe it's out there and I'm unaware, but that's really important as well. And again, we're not in cahoots, I swear, but building that user community. I wish I knew more people on this campus that were using similar resources. I wish I could learn more about what they're doing, because maybe I won't be bugging Rachel as much anymore. Not that she's ever suggested I'm bugging her, by no means, but you feel like being a little bit self-sufficient, right? So those are my lessons learned, whatever they may be worth. I do need to give a shout out. I think I'm going to stop here and see in what couple of minutes we have time for a question. Please don't ask Google Maps questions. He sits back down.
Yeah, when I go to googlemaps.com and click on that one, no. Thank you. This was a great talk, great work. I'm curious, I assume that other states have cartography offices?
No.
Really?
Nope. We are unique. State cartographer's office in Wisconsin was established in 1974, 50th anniversary.
Not even Nebraska?
Not in Nebraska. Nope. Nope. There was in the 80s, maybe half dozen or so, but we are very unique that we're at a university We were put at the University of Wisconsin to be insulated from state politics for very specific reasons, because we do work with state governments, local governments as well. There are many what are called geographic information officers, which typically sit in our equivalent of the Department of Administration. They might be more in an IT division, if you will. But as far as state cartographer, my boss is the state cartographer. We're very unique.
So I guess my real question is, I think you're doing great work here. Is there a way or a venue that you can share this with your peers in other offices? And a conference, workshop?
Yes,
And I think we would be happy to help you present that.
yes. Short
Volunteering
answer,
Rachel
yes.
some more.
Yeah, she's typing away back here. Yeah, seriously, the short answer is yes. I think it's getting past that, like, wow, this sounds, I tend to work more in government than I do higher ed. So whether that's an appropriate utilization of some of these things, I need to learn more, but absolutely happy to talk more.